These stacked rock layers represent a physical record of the Earth's 4.56 billion year history. Geologists read these strata to understand how new geologic features form and old ones are destroyed. But a number like 4.56 billion is almost impossible for the human brain to truly grasp. To make sense of it, we're going to shrink that entire timeline down into a single 365-day calendar. By mapping billions of years onto a familiar 12-month grid, those abstract numbers turn into a visual map you can actually read. Grab a pen and paper. Start by drawing a simple grid. We need 12 empty boxes to represent our year. In the very first box, January 1st, write down our starting point, 4.56 GA. Now go all the way to the end. Mark December 31st as 0, or today. Let's define our terms. GA stands for gigaannum, meaning billions of years ago. MA stands for megaannum, or millions of years ago. Setting up these hard boundaries gives us the exact framework we need to properly scale the physical and biological evolution of the planet. Let's start filling in the dates. Right at January 1st, mark the Earth forming from a swirling cloud of dust and gas. Just a few days later, around January 4th, or 4.51 Ga, plot a massive, glancing collision with another planetary body. That impact formed our moon. We call this early period the Hadean. The surface was a landscape of mostly molten rock, slowly cooling into a dark sphere. Because the early Earth was so hostile, very little rock record remains of the first half-billion years. Instead, scientists look at imagery like this photo from the Curiosity rover on Mars to visualize what a dry, lifeless, rocky landscape looks like. The takeaway for our calendar is that the entire first month is characterized by violent meteorite bombardments. At this point, the environment is completely lifeless. Skip to mid-March, 3.5 GA, and plot the first primitive bacteria. Sweeping past April and May, we land in mid-June, 2.5 GA, marking stable continents and rising atmospheric oxygen. Now leave July through October completely blank. For over half of our calendar year, the planet's only inhabitants were microscopic organisms, slowly terraforming the atmosphere so larger life could eventually breathe. The long biological silence finally breaks in late autumn. Go to November 18th, or 541 million years, and draw a massive star. Label this the Cambrian Radiation. This exact date marks a rapid emergence of complex marine animals, including the first organisms with hard shells. Everything we typically think of as nature, plants, insects, fish, and land animals, only exists in the final 6 weeks of our entire calendar year. On December 11th, reptiles evolve. Around 200 million years, Pangea formed, meaning a dinosaur could walk from New York to Cape Town. Then on December 25th, 65 Ma mark a large X for a massive meteorite impact. Look at these skeletons. This impact event wiped out the dinosaurs and reset the biological landscape, allowing mammals to take over. Despite their dominance in popular culture, the reign of the dinosaurs occupied a brief 2-week window right at the end of the year before being erased from the planet. Zoom in exclusively on December 31st. We introduce K, or kilo annum, thousands of years ago. Mark 11:42 p.m., 200 K, as the first appearance of Homo sapiens. All recorded human history happens in the last 30 seconds before midnight. Human history occupies a mere 0.0001% of the Earth's timeline. Our entire existence is a fleeting final moment in deep time. Look back at the completed grid. The physical layout makes the reality clear. Months of empty rock and simple bacteria, followed by a burst of complex life at the very end. When you look at landscapes like these dunes in the Namib Desert, remember that they, and every other feature we see today, represent only the final seconds of our calendar. It invites us to consider how much of the Earth's history occurred before a single grain of this sand ever moved. You now hold the entire biography of the planet on a single page. It gives you a scientifically accurate lens for viewing exactly where we stand in the history of the world.